In this video, we're going to look at the laws of exponents, which will help us to further simplify expressions. So let's first look at the multiplication law, which states that if you have a number raised to an exponent, and you have the same number raised to another exponent, then when you multiply these things, you're going to get a to the m plus n. What does this mean? All right, let's look at an example. That's the best way to see what this actually means. So let's say we were multiplying a to the third by a to the fifth. My argument is that a to the third times a to the fifth will give you a to the, we're going to add the 3 and the 5, and we'll get a to the 8. A to the 8th. Well, why does this work? Let's see. Well, remember that a to the third really means a times a times a. We have 3 a's here, right? And remember that a to the fifth means, and let's do this in another color, a times a times a. This is very exciting, isn't it? Times a. All right, there's 1, 2, 3. There's 5 a's. So a to the fifth is over there. All right, and in all, that is actually a to the 8th, and that's why that works. So just remember that when you're multiplying two numbers, well, the same number with different exponents, or the same exponent, it doesn't matter, but the numbers have to be the same. We have to add the exponent. So when you're multiplying a number raised to exponents, we must add the exponent. But again, the numbers, the base number has to be the same. All right, and this would work with values too. So for example, 2 to the third times 2 to the 20th. I am not writing that all out, but that would be 2 to the 23rd. All right, let's look at another rule. The second rule that I want to look at is the fact that a to the m, if you're dividing by, again, same base, but you're dividing, you're going to end up having to subtract the exponents. Why does this work? Well, again, let's look at an example. Let's say you have a to the 7th, and you're dividing by a to the 4th. Well, that's just going to be a, oh, why did I make so many a's? Okay, let's just get that in. 1, 2, 3, 4, 5, 6, and 7 a's over 4 more a's. 1, 2, 3. Next time, remind me to pick a better example with less numbers or less variables. All right, so a's will cancel again, a's will cancel again, add one more time, and we are left with a to the third. So we didn't actually have to do all that work. I just wanted you to see why it is that a to the m over a to the n, all we have to do here is subtract the exponents. Okay, so my third law that I want to go over is the fact that if we have multiple things being raised to a power, it's the same as raising each one to that power. And let's see how this actually works. Let's look at an example. All right, so I just learned my lesson. I'm going to pick a smaller exponent here. So I'm going to do a, let's use a different variable for the fun of it. Getting daring here, I'm going to use xy instead of av to the third. And my argument is that this will be not a, see, taking chances. All right, x to the third, y to the third. But why? Well, what's the reason? All right, so let's see. xy to the third is actually xy times xy times xy, right? There are 3 of them, xy to the third. All right, and it doesn't actually matter where the x's are and where the y's are. So we can rearrange that to be x times x times x, right? Those are those 1, 2, 3 x's times y times y times y, which in fact is x to the third, y to the third. So if I raise something, two things to the power of m, that means both things are actually, each thing is raised to that power. So that's an important one. And one more. Okay, so my last law that I'm going to go over in this video before we do one practice question and put it all together is that a to the m, all raised to the n, I call it power to the power, is equal to a to the m to times n, a to the m times n. And why does this work? And the best way to see is to look at an example. I'm going to throw in a number in this example just to make it fun. And by fun, I mean fun. All right, this is going to be a whole lot of 2's, but that's okay. All right, so 2 to the third to the fourth means that we're going to take 2 to the third, which you know is 2 times 2 times 2, and we're going to multiply it by itself 4 times. So we have again 2 times 2 times 2. 2 times 2 times 2. This is very, very exhilarating, I know. And 2 times 2 times 2. All right. And if you count all the 2's that are being multiplied by itself there, you should get 2 to the 12th. All right. To avoid having to write all those 2's here, we could have just multiplied those exponents. So the power to the power rule, we have, again, I'll just point it out for us again. Power to power, we can multiply. If a power is raised to another power, we can just multiply the powers and we'll get the answer. So a to the m to the n is a to the m times n. All right, let's try one nice big fun example. All right, so in this example, we get to put everything together, which is why it is awesome. All right, so the first thing that I want to do is raise everything in these parentheses to the third power. And I'm going to write it out. Everything gets raised to that third power. So we have 3 to the third power times x to the fourth power to the third power. So we can just multiply. If you remember that rule we just went over. Times y to the fifth to the third power. And again, we can just multiply over x squared to the third power, so again we can just multiply that there, and all of this gets multiplied by y squared. That lonely y squared off to the side just stays right there. All right, let's simplify another step. 3 to the third power gives us 27, and then we have x to the 12th, y to the 15th over x to the 6th, and again I put back my lonely y all the way over here. Okay. Now we can subtract exponents. I think that looks like a good way to go. All right, so let's do that. We get 27, and the exponents that's being subtracted are x to the 12th and x to the 6th. And that gives you x to the 12 minus 6, which is 6, y to the 15. All right, we are almost there. All of that is being multiplied by y squared. All right, so now all we have to do is simplify those y's. We have a y here and we have a y here, and they're being multiplied. So that means you're supposed to add those exponents. And we get 27, x to the 6th, y to the 15 plus 2 gives us 17, and we're done.